So today I'm just going to review with you all of your kinematics equations that you're going to need for chapters 1 and 2 and 3 as you go through one-dimensional motion, as you go to two-dimensional motion. You'll also need these equations for the rest of your mechanics portion. So we're just going to discuss it from a very straightforward and simple perspective. There are a couple of equations you definitely want to remember. First of all, you want to know the average velocity equation. Your average velocity equation is simply the change in displacement over the change in time. You can write it as d over t. Some people will write it as a change in displacement over a change in time. What is a change in displacement? A change in displacement just means your final displacement minus your initial displacement. Some authors, some textbooks, some teachers will write df for final displacement and di for initial displacement. I'm just going to write d for final displacement, and whenever I want to talk about initial displacement, initial velocity, I'm going to put a 0 as a subscript, and that's called a knot, as in you're tying a knot in your shoelace. So that's d naught. That just means initial displacement. That means final displacement. And your change in time is written the same way, final time minus your initial time. Now, many times your initial time is 0. So if your initial time is 0, this disappears, and you're just left with your final time in the denominator. That's why I wrote the final time in here. And many times your initial displacement is 0. If you're starting off from 0, then this becomes 0. So your equation just simplifies to d over t. So that's why I wrote it up here as d over t. This is average velocity. Average velocity is displacement over time. Now remember, displacement is different than distance. Displacement means how far are you from where you started off. So ask yourself, if they're talking about a football player, a basketball player, a soccer player, a car, a motorcycle, a plane, ask yourself, where is the plane, where is the car, where is the motorcycle now compared to where it was earlier? That's the displacement, how far it has been displaced. So displacement requires knowledge about direction. Which direction is the car going in? So if you take, if you go in one complete circle and you stop where you started off, then your displacement is 0. So keep that in mind. Displacement differs from the other term, which is distance. Distance doesn't care about direction. You could go right, left, make a circle, don't make a circle, go up, down. This distance just cares about how many steps you've taken, how many meters you've moved. Distance does not care about direction. So if you go to the right 5 meters and you go to the left 5 meters, distance would say, look, you moved 10 meters. However, if you went to the left 5 meters and you went to the right 5 meters, you're actually exactly where you started off. You end up where you started off, so your displacement would be 0. And your teacher is going to review this with you. Your teacher is going to discuss the difference between terms that take direction into account and terms that don't take direction into account. The terms that take direction into account, as well as a measurement, those terms are called vectors. The terms that don't take direction into account are called scalars. So anyways, that's for a later discussion. Right now I just want to review some of the important equations that you need to keep in mind for your kinematics discussion. And that first one is average velocity is displacement over time. How far you move over a certain time period. The other important equation you also want to remember that also discusses average velocity. Average velocity is equals to final velocity plus initial velocity divided by 2. This is easy to remember because how do you take the average of two numbers? You simply add them and divide it by 2. So if you talk about how do you find out the average velocity? You take the final velocity, you add it to the initial velocity. Remember that, there's a plus here. You add it to the initial velocity, then you divide it by 2. So both ways are viable, good ways to calculate the average velocity. And of course, we're taking into account that the acceleration is constant. The acceleration is not changing. If the acceleration does change, then you've got to break your problem out into pieces, and you've got to discuss each part separately as those parts have constant acceleration. So these equations are based for constant acceleration. And that leads to the next important equation, acceleration. Well, what's the definition of acceleration? Acceleration means my speed is changing, my velocity is changing. So acceleration's equation is very simple. It's how my velocity is changing with respect to time. If I'm accelerating, I'm speeding up. My velocity is changing. My velocity is increasing or decreasing. So final velocity minus initial velocity, that's how you say a change in velocity, divided by how much time has passed. You could have a positive acceleration, you could have a negative acceleration. Negative acceleration can be referred to as a deceleration, but as physicists we don't like to discuss it as a deceleration. We just call it a positive acceleration and a negative acceleration. Typically to the right we call that positive, so any acceleration to the right we'll call it positive, any acceleration to the left we'll call it negative. But you can choose whatever standard you want to use as long as you put a key on your paper saying to the right's positive, to the left is negative, or to the left is positive, to the right is negative. You decide. The traditional method is that up is positive, down is negative, right is positive, left is negative. So you can have a positive acceleration or you have a negative acceleration. This is an easy equation to remember. Final velocity minus initial velocity over time. This has a minus in there. The average velocity equation has a plus in there. Now this equation can be rearranged, and that's something I recommend for you to do. I want you to practice your algebra skills. I want you to rearrange all of these equations for the variables that they aren't already arranged for. So this equation is solving for average velocity. Try practicing rearranging this equation to solve for initial velocity. Then come back to the original equation and try practicing rearranging this equation for the final velocity, because your algebra skills need to be on par. You need to be quick with those algebra skills of moving variables around. So practice that. Same thing over here. Practice rearranging this equation to solve for final velocity. Practice rearranging this equation to solve for initial velocity. Practice rearranging this equation to solve for time. So for example, if you wanted to rearrange this equation for time, you'd multiply time on both sides and take time to the left, and then you divide acceleration by both sides and take acceleration to the right. And what you'll end up with is this. All I did was I multiplied time on both sides. Time is being divided on the right side, so I have to, if I want to take it to the left side, I have to multiply. And whatever I do on one side, I have to do on the other side. So I multiplied time on both sides, and I take time to the left. But now I want to get rid of the a, and if the a is being multiplied with the time, and I want to take it to the right side now, so I can isolate time by itself, I will divide both sides by a. And so you derive an equation like that. It's a good idea to practice rearranging these variables so you can get your algebra skills ready to go for this class. You can rearrange this equation to solve for final velocity. Final velocity is going to equal initial velocity plus acceleration times time. Now I'm jumping to the final step. I'm jumping to what the equation is going to look like. I'm skipping the part where I'm showing you, hey look, if I wanted to solve for final velocity, if I wanted to get final velocity by itself, the first thing I had to get rid of was time. So I multiplied both sides by time, right? I multiplied time on this side, I multiplied time on this side, so time disappears. And so now I have AT equals V minus V naught, final velocity minus initial velocity. Now if I want to get rid of the initial velocity, I want to take the initial velocity to the left side. Well, you have a minus V naught over here. It's being subtracted on this side, so to take it to the left side, I need to add it. So you would add V naught on both sides. And so this would get rid of the V naught, and you're left with just final velocity. Final velocity is equals to initial velocity plus acceleration times time. Final velocity is equals to initial velocity plus acceleration times time. So these are important equations. It's a good idea to practice moving these variables around so that you're very good with your algebra skills. So some of the important equations for your kinematics discussion for one-dimensional motion and later a two-dimensional motion are these equations that I'm putting up on the board. You don't actually have to memorize them because they're common sense. Average velocity is displacement over time. Average velocity is final velocity plus initial velocity divided by 2. Acceleration is final velocity minus initial velocity over time, or final velocity is initial velocity plus acceleration times time. Now, how do you get the other equations your teacher is going to show you? You play around with these equations. That's how you get them. You grab one equation, substitute it in another equation, you simplify, and you can derive other equations. I'll show you one example. I'll do it for one of the equations. I'll basically take this equation and this equation. We've got average velocity and average velocity. Average velocity is displacement over time. Average velocity is also final plus initial velocity over 2. So if both are solving for average velocity, I'm going to set these two equations equal to each other. And I'm going to just start playing with the equations. I'm going to rearrange them, plug in other equations inside them, see if I can derive a new equation. So I have distance over displacement over time, final velocity plus initial velocity over 2. Now I see if I have a final velocity here, and I also have an equation that describes final velocity. Final velocity is initial velocity plus acceleration times time. So if final velocity is equal to initial velocity plus acceleration times time, I'm going to plug that in here for final velocity. So instead of writing final velocity, I'm going to write down what final velocity stands for. It stands for initial velocity plus acceleration times time. And then of course, I've substituted this value for my final velocity. I still have the initial velocity, and I have 2. Now you can do whatever you want to do. You can simplify this, so d over t. I'm going to bring out the v naught. So you have v naught plus at plus v naught. So the v naught plus v naught becomes 2 v naught. So you can, in the next step, show it, or you can show it right here. Instead of just writing them twice, you can just write 2 v naught. Okay? And now, if you want to simplify this further, you can put the 2 and relate the 2 to the 2 v naught and the at. So you'll have d over t equals 2 v naught over 2 plus at over 2. You'll notice the 2's are going to disappear. They're going to cancel each other out. So now you have d equals v naught plus at. You can take the t over, and if you do that, that's what you get. You get d equals v naught t plus at squared over 2. This equation is one of your kinematics equations. Your teacher is going to give you this equation. It's going to look like this. See? at squared over 2 is the same thing as 1/2 at squared. Right? At squared over 2. v naught t, v naught t. This also takes into account initial displacement. This one didn't have initial displacement because from the beginning I just wrote down final displacement. I made the assumption that the initial displacement was 0. But if I did do that and I said, look, final displacement minus initial displacement, then you'll notice that the initial displacement will come back into the equation. You can put that in here, d minus d naught, and then you can take the d naught over, and you'll have d naught plus v naught t plus 1/2 at squared. And this is one of your kinematics equations. All I'm trying to do is show you a couple of things, which is one, you have some standard basic equations that come from definitions. You don't have to memorize anything, you just have to understand the definitions of these terms. The second thing I wanted to show you was that you can rearrange these equations to solve for other variables, and that's a good practice. Rearrange this equation to solve for final velocity. Rearrange this equation to solve for initial velocity. Rearrange this equation to solve for time. Do that for the other equations too. And finally, the third thing I just wanted to show you is that how do you derive these other equations that your teacher is going to give you? You derive them by taking some of the given equations and you play with them. You get creative. You substitute them into each other. You set them equal to each other, substitute other equations into them. You simplify, and you can derive these equations. So I just wanted to show you how to derive these equations. Another one of the equations that your teacher is going to give you is this. Valuable equation. Final velocity squared is equal to initial velocity squared plus 2ad. And it's a good idea that you practice figuring out how to get this equation. Take this equation, take this, take this, take this, substitute them into each other, play with them, get creative. See if you can use these equations to come up with this one. Just like we use the average velocity equations to come up with the displacement equation, which is this one. See if you can practice trying to figure out how to come up with this equation. That may be a good practice of using variables, mixing equations with each other, and going on from there. So, hopefully this was useful. But these are your kinematics equations that are going to be useful for your one-dimensional motion, for two-dimensional motion, and they'll show up again and again and again. So I just wanted to make sure you were comfortable with them.